So we haven't talked about, but the topic that you were doing previously was all about rational functions, rational equations, rational expressions. And it's because we have a fraction, all right? And we have the x as part of the denominator or as part of the numerator. So when we've got that situation, we have this, what we call a rational expression, all right? So what we want is we've got this expression and we want to solve where that is equal to 0. All right, so we need to understand what that means. If we then go to Desmos, so this is an unfamiliar one where we could solve it algebraically. You guys probably should be able to do it, but we're going to do that graphically. All right, so in our graphing software, we're going to put 1 divided by x, subtract x in. And this is the curve I get. You will sketch it in your book to show what your calculations are. I'm just going to do this. So there's the graph of 1 over x minus x. How do I know where that is 0? Using the graph. Timo? When you say above the 0, what do you mean? Okay, so the x-axis, do we remember what the equation of the x-axis is?
Y equals 0.
Y equals 0. All right. Are you taking notes on your computer? No. You would type. Therefore, what's this value equivalent to? Where we say 1 divided by x minus x is less than 0, what are we actually saying needs to be less than 0? Which coordinate? So a graph is all about x coordinates and y coordinates that go together. So for instance, if I've got a point here, what do I know about, without giving me specific numbers because you can't, that's why I picked it, what do I know about the x coordinate? Positive or negative? So this is a negative number. What do I know about the y coordinate?
Positive.
It's positive. Okay. If I pick a point down here that makes, right, what do I know about the x coordinate? Positive, and the y coordinate is negative. All right. So what I'm looking for when I'm interpreting this inequality is I want to really know what x coordinates gives a y value that is less than 0. So which x coordinates can I choose that will give me a y coordinate less than 0? So on the graph, where do I see coordinates that are less than 0? So Thibaut said it's where it's under this line. So what I'm looking for is to identify the x coordinates that give me these points. Yeah?
Mm-hmm.
Make sense?
Yes.
So, what are those points? So, clearly, it starts here, yeah?
Mm-hmm.
And it also starts here. So, on my computer, I think you were going to say, that's why we did it.
Yes.
We want to know this coordinate, and luckily, we can just go, oh, there we go. It's at
-1,
-1, and this one is at 1. So I can put that in my little sketch. All right, so I know that that is at -1 and this is at 1. So the solutions to my inequality are x must be
either between -1 or equal to, and then
hang on. Let him finish.
no.
Ah. Well,
And but smaller than 0,
okay.
semicolon, x must also be greater than 1.
That's it. Okay, good. All right. Why not the and equal to?
Because it. Oh, go ahead, Tia. Take it away.
Because it's smaller than 0.
Yeah, up here, look, we had a
Yeah.
not equal to 0. So we can't have the and equal to. So I'm interested, Greg, where does the 0 come in?
Well, I mean, you're gonna see on the graph. I mean, there's 2 lines.
Yeah.
And then so the asymptote is 0. So then anywhere between.
Okay, good. So the asymptote, this is just what I'm after about it, because this was difficult for some people, is that here is an asymptote, and what's the equation of that asymptote? X is equal to 0, because we're not allowed to put x is 0 in. And we were discussing this. So what happens, what is the behavior of this line as I get closer and closer to 0?
Tends towards.
Ethan. So if I pick x values that closer and closer to 0, what happens to the y value? Where does it end up?
If you take x values that go closer and closer to 0,
Yeah.
what will the y value be?
Yeah, what would the y value be? So I'm kind of Greg, has identified that if I use these x values and then if I use those x values, all right, I'm good with my inequality. But what I'm asking is, so what behavior does the function show as x gets really close to 0 from the negative side? So I'm kind of saying, well, if I picked -1 and I'm going towards the 0, what is happening to the function? Where is it going?
The y value
Yeah.
goes closer to x equals 0, but goes further down.
But what's the y value that we're getting? As if I pick, for instance,
Oh, the y
x
value
equals
is
-1, whatever, really small number. That's really close to 0 on the negative side. What would the y value be? Big, small, indifferent? T-Bone?
Very close to 0.
Wouldn't actually.
Close to 1.
Nope.
Or is it already?
This thing, do we have a true understanding of what a graph is showing me? Yeah.
Wait, pardon?
I'm a little confused. So I've plugged in what you've plugged in.
Yeah,
1 over x minus x.
yeah,
And then I've added the is less than 0.
yeah, but I didn't do that.
No.
No, and then it has exactly what we
Yeah.
have. What you see the teal line.
It shades in a
It
region,
shades
yeah?
in where it can be.
Yeah,
So-
but it's just shading in like this.
Yeah, 'cause
Yeah.
that's the region.
That's the region, isn't it? So if I did, if I put in what you've done on top, just to show everyone what we're talking about, is less than 0. So you can see the region that we've just talked about, yeah?
Oh.
So if you look at what we did on paper, I've got that region there. I've not shaded in the whole thing. I've only picked the x values. So back to my question, which is, what happens to the y value as the x value gets infinitely close to 0 from a negative direction? It's not getting close to 0. It's not getting closer to 1 from, okay, and ends up being, if I get infinitely close to 0, it will be infinitely large in a negative sense, yeah? This line goes down.
Oh,
As soon as I go the other side, so let's say x is now positive 1, whatever, billionth, whatever, where would y now be?
Positive 1 billion.
Yeah, the other way, it's coming back down, isn't it? So we're on this side. So this would be a positive infinity thing, and this would be a negative infinity thing, right? That's why it's an asymptote, right? You remember that about asymptotes. It's because we get infinitely close, all right, but don't quite get there. So that's the behavior. we need to then discuss, so the solutions are these. If I were to ask, just because of unit 10 or topic 10.2, what is the domain of the function? Now, we've already taken it into consideration when solving the inequality, but what is the domain of the function?
What's the domain again?
The domain, before we consider the inequality, are all possible x values that could go in, ignoring the inequality. So we would say that, so x belongs to the set of real numbers, but x cannot equal 0. Yeah. So before we introduce our inequality, any x value can go in, yeah, apart from 0.
Wait, but so it's not shading 0? So
You can't shade 0.
I know, but like, would you say if x can't equal 0, then like on the exact axis, it's not?
It's this
shading?
red line down the middle. It's not the one you were looking at.
Oh.
X can't be 0. How do I know
X
x can't be 0? Because you can't put x as 0 into a fraction, if that
Wait,
makes the
but
denominator.
still, like the shading is.
Right, there is no shading at this point.
I know,
That's why I didn't ask you to do shading. Shading gives me an inequality. I'm not asking for an inequality. Right? Before we
If you
consider the
rearrange
inequality.
this function, could it be?
Oh, yeah.
Okay.
All right. What about the range of this function? So that would be the y values. So can we say again that y can be any real number? Is there any y value that will never happen? Is there a y asymptote? No. Right? This will always give me a number. If I chuck an x value in, it will give me any number of y I like. I can get using that. All right? So therefore, my range is just that. All right? The only restriction, as we were talking about, is this. So let's have a look at another one before I let you get on with the rest. Let's have a look at C instead. All right? So we'll start with domain and range. Are you with me? So C is x plus 6 divided by x plus 1. All right, so I'm not going to do the is greater than 2 yet. So just that as a function, say if y equals that, what would be the domain of that function? Greg?
X belongs to real numbers besides -1.
X is not allowed to equal -1. All right? But the range. Before you plot it, any ideas? Before you plot it. Before you plot it. Before you plot it.
So the range is anything y can be, correct? Right? Okay.
So yeah, we've got y can be any real number. We'll chuck that in to start with. But is there anything y can't be?
Y cannot equal. a
Surely it
negative.
can't be above 1.
No. Yes, it can.
Can't be above 1. It always must be less than 1.
No, it can't be below 1.
It can't. Y can't equal a negative number.
Because
Why?
right, even if y is 1,000, or x is 1,000,
Oh yes,
right?
Y can definitely equal a negative. I don't know.
1,000, and then it would be 1,000 plus 1. But then the
You'd have
whatever
1,000 plus 6
it's
on
the
top.
1,000 plus 6. So then it can't be below 1. But if it's a negative x, it would
Be below.
1. It would be below 0.
Below 0.
So 0 to 1, it cannot be.
Can we see what Greg's talking about though? Can we see that there is potentially a y value that we can't have?
Yes.
Maybe?
Right.
Should we have a look then? What is it graphing wise?
Two asymptotes.
Yeah. So let's put in x plus 6, wasn't it?
Yes.
Let's do this properly. So we're going to do x plus 6,
Ah, it is.
and it's all divided by x plus 1. Okay. So, there
Oh,
we
no,
go.
it's just 1. It can split
Okay.
with 0.
So I think you're right, though, aren't we?
Yeah,
That we
can't
do
be one.
have 2 asymptotes. All right. So let's just take the screen.
Oh, so the domain is wrong too.
Is it?
Huh, okay.
Is the domain wrong?
Well, yeah, because x can't be -1. At least from what I'm looking at.
Well, that's what we wrote.
Oh, okay, never mind then.
So we already decided, didn't we, that x being -1, that gives me this asymptote, yeah?
Yes.
We were happy,
Yes.
we're expecting that. But then we've got this one here that is y can't equal, is never going to equal,
Determined to find
1.
crossing that line.
It's not going to
It's
happen,
never
Nick. So
gonna
stop.
happen.
Do you remember we talked about misuse of time?
Yeah.
Yeah? Inappropriate use of time. All right, focus on what's important. So what about the range? So can we say that the range is that y cannot equal to 1? Is there any way of looking at that then and deciding that?
Yes.
Same two people. Anyone else? Y will x plus 6 divided by x plus 1 never equal 1. Aisling.
Well, this might be wrong, but when you do it and you multiply it to find the value of x, it would be x plus 6 equals x plus 1, and that can't happen.
Yeah,
So,
that can be true, can't it? I mean, the other thing, how do I get 1 when I've got a division?
The top and the bottom have to be equal and they can't be
Yeah,
equal.
so two ways of saying the same thing, but as Aisling said, x plus 6 will never equal x plus 1 unless we've got 2 different values for x, and we don't. X is the same number. So that gives me a clue, doesn't it? It's about the fraction stuff again with these rational functions. So we've got that clue. Y will never equal 1, so we've got another asymptote. Right, now we add in our inequality. So we're doing 2 topics at the same time here. So we need to solve x plus 6 divided by x plus 1 is greater than 2. So we can add in another line, can't we? Yeah, and where would I put that line? Yeah, y is equal to 2. So let me put another line across here like this, and that's going to be my y equals 2 line. All right, so now I want to know where is x plus 6 divided by x plus 1 greater than 2. So I'm obviously looking at this point here. Yeah?
Mm-hmm.
So are we happy that which way do I go from that point? See that?
Down.
Backwards, yeah? So I want to know where the black line is above. So I'm interested in this bit only, right? Again, that's where my knowledge of asymptotes is important. I know there's an asymptote. Thibaut?
x is greater than -1
X is greater than -1,
and smaller than 4.
smaller than 4. Zoe, where did we get the 4 from? Where did Thibaut find 4?
It can also.
the dot is on the
It could equal.
How do I know it's on the 4?
It's not on the 4.
How did Thibaut decide that was a 4? Put your hand down, Greg. It's a really, 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 really easy question. I'm just checking how with us you are. And I think my answer is not very. Nick, how would you find a 4? How do you know it's a 4 or not? No, you're not with us.
I know,
Ethan,
I know.
how would we know it was a 4 or
I
not?
only knew because.
Come on, Greg, put us out of our misery.
So there's two ways. Number one, you can just do the equation x plus 6 over x plus 1 equals 2.
Yeah.
And then the other way, actually, I think that's the only way.
No, it's not. The way that I'm asking for is I go to my
The
computer.
other way is because 6 minus 1 is 5, and then if you know it's negative 1.
I'm actually just asking for, if I put y equals 2 into my computer, all right, this is what we're saying, and I just click on it, and it will tell me, all right, and it will tell me the answer's 4.
Okay.
That's what I was after. Yeah, that's why we've got computers open.
Of course.
Yeah?
I mean, my computer says
For
it
some reason I
doesn't.
thought it was some complex.
No, well,
My
that's what I mean.
computer says it doesn't equal 4.
Then something's wrong, because I've just shown you it does.
I know, but it's not exactly.
Well, what's your y value on that coordinate? Not exactly 2?
No, it is 4, but it's just a dotted
It's a
line
dotted line, so it's not like it's not including 4.
because it's greater than 2.
Because
not greater
you're
than or equal
insisting
to.
on doing the inequality signs again, yeah?
I just wanted to see it.
All right, okay. So we have our solutions then. Minus 1. Are there any other solutions in this sense?
It could also equal.
Greg?
You could do the equation x plus 6.
Now, are there any other solutions?
besides
Is
that.
there any other way of getting it?
I don't know what you mean.
Well, I've got, can x be anything other than between minus 1 and 4?
Nah.
No. Because the line is, that's the only bit of the line that is above the blue line. That's it. Yeah? So we're looking for those. Now, as for are there any other ways of finding that point algebraically? Well, should we have a look just in case? So we've got x plus 6 divided by x plus 1 equals 2. What would you do? Multiply by x plus 1. This is kind of what Aisling was saying before. So we've got x plus 1. Expand the brackets to 2x plus 2. Subtract x. And then subtract 2. There you go. Got it.
I would have just did.
Algebraic approach. This is why, again, we've been dealing with rational expressions to enable us to do it. Right? But now I've got the graph. Right? Now, if I didn't have the graph in front of me and I did that, and then I was asked to solve x plus 1 is greater than 2, what would you then do? Would you write,
It must be.
so you'd end up with the x and less than 4? Because I've just,
Doesn't that have to be greater?
Nah. Less than.
I mean, we're happy with less than 4, aren't we?
I am.
But where does the other part come from, Aisling?
Well, it comes from the denominator.
Okay.
It comes in the domain.
Do you remember we solved one the other day and we got x equals 2, which wasn't a valid solution? But in another sense, we have in this case, the only solution we get is the x must be less than 4 solution. So if I write that the other way around, but we are missing this side because we have to know about the asymptote. And if we don't know about the asymptote, we only get half an answer.
Wouldn't x also be able to be greater than 4? Like, say for example, you put 5 in.
Okay.
11 over
5 plus 6 divided by 5 plus 1 needs to be greater than 2. Is it? 11 divided by 6 is definitely less than 2. Yeah? And you can do it, right. What's 100 plus 6 divided by 100 plus 1? Well, I think what we've already decided is the 100 divided by the 100th thing. You know, so the difference is the 6 divided by 1, right? For this to equal 2, this would have to be 106 divided by 53. And it's never going to be that, is it? Ever, right? If x and x are the same, it's never going to be that either. So, all right. So we've got lots of components to it there. We've got the domain, the range, the asymptotes, we've got the being able to solve the inequalities, we've got the graph, all of those things, 2 topics all in one. All right. So in practice 2, you've now got A, B, C, D, E, F, G, and H. All right. It says just find the inequality solutions, but I want you to consider the domain and range of each function first, if you can, please. All right. Now, just to say, your answer